Alrighty, everybody. Hello, hello, hello. Finding the exact values, eh? Alright. Well, we're gonna do some more here, people. Definitely, these guys here look pretty good. I'll do number 6. All right, I'll start there. All right, find f prime of pi over 3. Alrighty. Given the function f of x is equal to sine x multiplied by tan of x. All right, so remember, sine times tangent, people. That's a product rule, right? F prime of x will be the first sine of x times the derivative of the second, derivative of tan, secant squared of x, plus the second tan of x multiplied by the derivative of the first. Derivative of sine is cosine of x. All right. Can we simplify this a little bit? Maybe. I'm looking at tan times cosine. Now listen, you don't need to, right? I mean, you could plug in pi over 3 now and just work it. But if you simplify it, it'll be possibly less stuff to plug into. So what do we know about tan of x? We know tan can be written as sine over cosine, right? Cosine is cosine. So cosine x over 1, right? There's no way to rewrite cosine. There's no way to rewrite sine. So that's what I meant when I'm like cosine is cosine. But I think we can simplify that, right? Sine over cosine multiplied by cosine. Right, you can cross out those cosines, right? So you just have a sine of x over there, right? So f prime of x is sine of x times secant squared of x plus just sine of x now, right? So that's what I mean. I mean, you don't have to do that because, we're just plugging in pi over 3, but, multiple choice, you might see that, right, as an answer instead of tan times cosine. So, just keep that in the back of your mind. All right, let's plug in pi over 3 now. So f prime pi over 3 is sine pi over 3 times the secant of pi over 3 squared plus sine of pi over 3 again. Pi over 3 radians, 60 degrees, if you remember. If that helps you, or you just, go back and look at the table. The sine of 60, or pi over 3 radians, is radical 3 over 2. So, I'll bring it up here, I guess. So, f prime of pi over 3 is the sine of pi over 3, which is radical 3 over 2, multiplied by the secant of pi over 3 squared. We'll get that in a moment. Plus sine of pi over 3, radical 3 over 2. Secant pi over 3 is, the secant function is the reciprocal of cosine, right? So cosine pi over 3. We'll go back. Can we fill it in over here? All right, cosine pi over 3 radians is a half, which means the secant of pi over 3 is going to be the reciprocal of a half, which is 2, right? So secant pi over 3 is 2. We'll square that. All right, so f prime pi over 3 is going to be radical 3 over 2 times 2 squared, right? So 2 squared is 4. So this is going to be 4 radical 3 over 2 plus a 1 radical 3 over 2, right? I'm going to leave that as is because I can go ahead and add the tops now, right? Because I have a common denominator here. So f prime of pi over 3 is 5 radical 3 over 2. Once again, that is the slope of the line tangent to this curve, sine times tan of x, at pi over 3 radians, or 60 degrees. All right, very nice. Let me do 7 also. Function here is 2x multiplied by secant of x, right? Multiplication. So this is one function here is my 2x. Secant is my other function. So this is another product rule. So f prime of x is going to be the first times the derivative of the second. So 2x multiplied by the derivative of secant. Here is secant x tan x. Plus the second times the derivative of the first. Secant x times the derivative of 2x, which is 2. So I'm going to write that as 2 secant of x. I guess could I factor here? Yeah, I could. I don't know if it would help me out, though, in terms of plugging in pi over 4, right? It's not like stuff would cross out like it did in the previous question with cosine. Right, I could factor out a 2 secant of x, right, from both terms there. But like I said, it wouldn't go away, so if you want to, you can factor out, but I'm gonna leave it here. I'm just gonna go ahead now and plug in pi pi over 4. So anywhere you see x, you're plugging in pi over 4. All right, tan pi over 4 plus 2 secant pi over 4. So 2 times pi over 4 is, that's 2 over 1, right, times pi over 4. That's 2 pi over 4, which is pi over 2. Secant pi over 4, tan pi over 4. All right, we'll go back to the old table there, yeah. Tan pi over 4 is 1. And what was it? Secant pi over 4. Secant pi over 4 is the reciprocal function for cosine, right? So cosine pi over 4 is radical 2 over 2. So the secant of pi over 4 is going to be 2 over radical 2. All right. All right, so secant pi over 4, what did we say, is 2 over radical 2. Tan pi over 4 is 1 plus 2 times the secant of pi over 4 again, 2 over radical 2, right? It's the reciprocal of cosine pi over 4. All right, let's see here. If you want, you got to multiply this and, and then add them up there. I could cross out those 2's, right? Do a little cross canceling here. You can if you want to. F prime pi over 4 is going to be, let's see here, what's up top? 1 times a pi, right? So a 1 pi or just pi over radical 2 times 1, which is radical 2, plus, this is 2 over 1 times 2 over radical 2, so 4 right over radical 2. That's nice. You have a common denominator. No need to rationalize. If you want to, that's fine. So f prime of pi over 4. Add the tops, pi plus 4. I'm just going to write as pi plus 4. It's not 4 pi. That's pi times 4 over radical 2. And there you go. That's the slope, once again, of the tangent line to this curve at pi over 4 radians. Also 45 degrees, right? All right, I want to do number 8, and then we'll see where we're at after that one here. Number 8. All right, number 8, not a product rule. Not a product rule here. This is going to be a quotient rule. All right. So f prime of x, here we go, is low times derivative high cotangent x times derivative of 5x minus high 5x times the derivative of cotangent. Derivative of tan was secant squared, right, of x. Cotangent is the cofunction of tangent, right? So secant squared, its cofunction of that's how I do it, is cosecant squared, but since it begins with a c, it's a negative cosecant squared of x. Over, don't forget, low times low, people, right? Cotangent squared of x. F prime of x. 5 times cotangent of x is 5 cotan x minus 5x times a negative, right? That's a negative 1. So those two negatives, right? Positive here. 5x, right? Cosecant squared of x over or cotangent squared of x. Once again, I mean, you can factor out a 5 with the numerator, but it's not really going to do much for you. So I'm going to plug in pi over 4. Right now, that's the derivative there. So we're going to do 5 cotangent pi over 4 plus 5 times pi over 4. Cosecant pi over 4 squared over cotangent pi over 4 squared. So we're back to the 45 degrees, pi over 4 radians with the cotangent and the cosecant values. Are you guys okay here with the, how we got the positive, right? I got the positive there because of the two negatives here, right? That's why the positive, the plus, right, is there. Pi over 4. Cotangent is the reciprocal of tan. Tangent pi over 4 is 1, so, you know, cotangent, nice, is 1. And then the other one we needed was cosecant, right? Cosecant here is the reciprocal of sine, right? So, we get the sine of pi over 4, right, is radical 2 over 2, so you just flip it, 2 over radical 2. All right, let's see. Where were we? All right, so 5 times cotangent pi over 4 is 1 plus 5 times pi over 4, that's 5 over 1, is 5 pi over 4 times the cosecant of pi over 4. So what do we say? Radical 2 over 2 flipped, right? So 2 over radical 2 squared over cotangent pi over 4, which is 1 squared. All right, so f prime of x here will be 5 plus, so 2 over radical 2 squared is 2 squared, right? So I'll have 5 pi over 4 times 4 over radical 2 times radical 2 for 2. And this is over 1, right? So I can get rid of that. These 4's would cross out, wouldn't it? Right, 2 squared 4, radical 2 times radical 2, right? That looks pretty good, would you say? F prime of x here. 5 plus 5 pi over 2. I guess that would be all right, but I probably would get a common denominator here just to tidy this up a little bit, right? Times that by 2 over 2. So that'll be 10 over 2 plus 5 pi over 2. Right, so I'll say, what here, 10 plus 5 pi over 2, right? That's nice and tidy there. All right, so there you go. Slope of the tangent line once again to that curve at pi over 4 radians, people. All right, so there it is, these exact values. So that's, coming into play here, all right, with the stuff